Great. Now let's look at our content today, turning web pages into data. So today, just an overview of what you will learn. So what and why of turning web pages into data. So what are we doing here and why we're doing it? And then later we'll just look at some examples, like sending HTTP requests and getting text from a website, and also like parsing structured responses and scaling up if we are doing like a huge load of tasks at the same time. We want to do it like async requests, and like the later part of the webinar will be automating web browsers, like you're using code to open a web browser and then doing things from there. It's also like one kind of technique for getting information from web pages. Great. So extracting data. What is extracting data? So we go to a web page and we want to systematically get information from the web page. For example, later we have an example of like a shopping website that we might want the price of the item, the name of the item, the description of the item, and then like later process them into more formatted data. And yeah, we can do it for like all sorts of information on the website, like text, images, or links. But I believe that as of today's examples, it is more of a textual information processing. So yeah, and the process of us doing it in a higher level description is that we find a website that there are something that we want to get the information, and then we look into the structure of the website, and then because websites are structured, that's why we can actually do it. And then we do some analysis on the structures, like, oh, I would like to take this part out, and doing it repeatedly so that we have a lot of information. And after we get the information, it goes back to like data processing. So yeah, that's the basic idea of what we're doing it here today. And also we would like to automate the whole process, because there might be several websites that we want to look at all together. We want to combine the data together. Then we might be talking about like thousands of web pages. So automating the process will be extremely helpful. Like just run a couple of lines of code and then you get all of the data. So yeah, why are we extracting the data? Yeah, basically it's just getting more information to do like data processing, and it is also depends on what your purpose of getting the data is. I can later talk about some of the like real life examples we have done by extracting data from web pages. But yeah, one of the things that once we get the data, then we can get it in the Wolfram language, and we can later do some like visualization, like maps, machine learning, LM training, and a lot of that. It's a combination with like just extracting data and also other coding techniques. So yeah, like later we'll just show once we get the data, then how can we process them. So here in Wolfram Language, it is made very easy. Well, like for two separate parts. Like first of all, for extracting data, Wolfram Language has made it easy using a couple of functions. Then it was pretty much automated. And on the other hand, after we get the data, the visualization, the manipulation of the data, machine learning, LM processing, like all of that is also pretty easy in Wolfram Language, I would say. So as for now, we're on version 14.3, and there are like 6,000, about 7,000 building functions. Maybe like one line or two lines of code will help you produce a lot of things, and as we will definitely show like in later examples. So yeah, now we're going into looking at examples. But first of all, importing web pages as text, there is some files. This robots.txt file that I need to mention. You can read the description here. So yeah, it's just basically like restricting what kind of things you can look into. So yeah. That aside, now we're looking at a real example. So first of all, let me take this link. Great. Let me just pull it out here. So this is a, you can say this is a example page for you to practice so that you're not like using a real website, which actually can change dynamically, which will increase like your workflow, like difficulties and a lot of other things to handle. But here we're just using a very basic like testing site, example site. So that will minimize like the changes later. So it's a pretty standard way of start to learn this kind of process. So first of all, let's look at the site. This is pretending to be a shopping site where you can buy computers and laptops. And as I go, you can see like has should have pictures, but that's not our today's point. And for each of the item, it has a name, has an item name, has how much the price of it, and also like a short description of that. So what we're going to do is to getting this out systematically and put them in one list. So yeah, during this webinar, I would assume that we have some basic understanding of HTML. So yeah, first of all, looking at a web page, we would like to understand the structure of the website so that we can actually do the processing. So I'm currently using Chrome, and it's about the same for like the for just a basic browser like Chrome, Firefox, Safari, something like that. So it is a pretty standard way to look at the HTML code of this website. So you right click and then you see this inspect. But yeah, in other browsers, it will be just about the same. So as here, you can see this like developer tools that when you go through, it will actually highlight like which this code is controlling on the left side on the real website. And you can also click this little button here. So it's more like backwards. So if you go through here and it's like you can see it on the right hand side where this link it's generated. So yeah, for HTML, the basic structure is like everything is wrapped in some tags. So for here, like a title will be just be writing like in here as a head, and you can see there's a like a title wrapper here. So yeah, for this one, for the price, we can see it's a span tag, and then it has like another like kind of like a name tag thing called price, and then in the middle is $2.99 is the actual information we would got. So the basic idea of getting this information out is taking all of this HTML information and we just process it as a string, and then we do some string processing. All right, so let me go back to my slide here. So in Wolfram Language, we use this import function a lot. So not only it is used as import a website here, we also use it to import files. We use it to import like data files, CVS, also can do image, yeah, all of that. But like for here, it is more of an automated process of getting the information from the website. Let me do that. Let me do the import. So now we're asking import to get this website as text format. So here we go. Yeah, it's pretty long, I would say. So we'll just look at the basic. You get the idea. It's the same as what I just showed in the developer tools in the browser. And sometimes, like if you're not sure what you're looking for, like basically you can just Control F and try to find the 299 in this code. But yeah, we have like all these different things. All right, now once this thing has got imported as a long string, then we can do parsing. So there are two different ways of doing the cleaning of the string. So yeah, we saw that for the product name and product description, it's like in this tag, it's a p tag with class equal to description card tags, and I believe there should be some like real description like tags here, and then it got closed by this p tag. So yeah, with that in mind, then we can match the string we're trying to find as in this format. So here we're using this string cases function, and this is our extremely long HTML text. And here we're just writing up how the structure should look like. So I start with this p class equals to blah, 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 and closing up with the with another tag. And in the middle, for this part, it's this kind of thing I put in the middle here. It's like it doesn't matter what the description is, as long as there's something in it, we'll get it. So yeah, when we run this code, all the matches comes here. So we get, you can see the structure here, description, and here we have the brand name, all of that. So get the idea. And this is for people that's more familiar with Wolfram language. We have this string expression, or we can also match the string cases for regular expression, which is more common in some other languages. But yeah, this is just some like syntax details that you can look up for the documentation, something like that. So yeah, this tool will mostly give the same thing. So yeah, for the first one, it didn't filter out the middle part. It gives you like everything with the tag, but it is pretty easy to take those part out too. But here, this one is more like just taking the middle description part. So yeah, get the idea. String matching is a very powerful method of parsing string data, but there are also some disadvantage of it because some of the patterns might be a bit more complicated for you to recognize, for you to construct. So it would be easier if you can go through like several layers of cleaning so that it's not like overkilling the actual information you want. All right. So yeah, this is more of a automated way, like import the site in. This is more automated. And if you wanna actually get one layer below it, you can use this function as URL read. And for this function, it will give you a HTTP response object, which contains actually a little bit more information than what we just saw there. So yeah, the text, it's actually in the body part. Let me show that. So yeah, it's the same as what import just got. But also, again, this contains a little bit more information than the automated one. So you can also get like some headers here. And this contains like more information if needed. So yeah, this is more of a manual way to get information, and there will be chances that the web page refused to be imported or refused to be read. Then you can basically try this way to see if that can goes around it. All right. So yeah, that's a testing example. So now we're looking at some real world example. So for this one, we're looking at this couple of companies, which are big companies in the UK. So first of all, we want to collect their contact pages in the list of associations. So first of all, we want to build the like what links we're looking at, like which company this is. And now we'll just have a helper function to get the information. So yeah, for here, you can see the regular expression. It means like this D means a digit, and there are 4 digits, and followed by 1 space or a dash, and then followed by 3 digits, and then followed by space or dash, or and then like later 4 digits. It's just like how the phone numbers are formatted. And this is the regular expression construct of the pattern. Is we can also do it in the string expression, noticing that this is a little bit longer than the regular expression, but sometimes it's backwards. The string expression will be easier to understand, and sometimes in some cases like shorter and easier in your mind to construct. So there's no right or wrong to choose like which one you would like to use. Like as long as it works, like either one is fine, and as long as it's easy for you to process, that's great. So yeah, this helper function will just first of all import from the link, and then we're looking at the web page, looking at the strings, and then taking out the part of information, which is phone number here, taking the information out from the string, and then we just make it back into a good looking format. All right, so now let's give it a try. It's pretty fast. So yeah, here we get Apple's number. It has 3, and Barclays, Monzo, Every. Yeah, noticing that the even though we have delete duplicates already, there are still like the first number and the third number looks about the same here. I actually looked into a deeper code than yesterday when I was testing the code, and it turned out to be that one of them have a space in between, and the other one has like a no line break space. But for us, like visually, it's the same, and we couldn't even tell. So yeah, that is a good point of like after your cleaning, there might be more cleaning that's needed, and there might be like some more reasons. So yeah, now we have this as a basic example, basic workflow established. If we want to get more other companies' information, how to contact them, we want to make a like a phone book or something like that. What we're going to do is we're just gonna populate our association here by giving the names of the company and then giving the contact page link for the company. And in this case, we can just get all of the information if we need it. All right, so yeah, now it's parsing the structured responses. And here we're looking at some news web pages. So now we're talking about XML. We've been talking about HTML for a little bit for this webinar. HTML, I think it's contained in the XML like big umbrella word. But yeah, I think XML is a little bit stricter than HTML. Yeah, HTML in a lot of modern web pages cannot be perfectly represented as XML. So yeah, now we're looking at the XML objects for a news website. So they have this thing called site maps for their news website. There are, yeah, let me get this link so we can look at how it looks like. All right, so yeah, this does not look like a normal what we usually see kind of website. It's just plain code, nothing fancy, nothing UI there, but it contains a lot of useful information like the news title and the link here. So yeah, what a sitemap is used for, it's usually for more complicated website that they wanted all of the link, all of the structure to be captured by search engines. So yeah, it is rarely used for our human, but yeah, for search engines, when they look at the news website, they know like what's updated and they know what to put on their pages. So yeah, basically like that. And I think it also helps with the SEO. I'm not exactly sure about that part, but yeah, so it's basically for like crawlers. to use to just get all of the information. Otherwise, if it's for like HTML, then it will be extremely hard to dig out like one small information. So that's where this sitemap comes into use. And as you can see from the short clip here, and it is pretty structured for every news to be the same structure. So we get the link, and then we get the time, and we get the title, something like that. I was wondering if RSS also used this thing. But yeah, now because it is more structured, and then we can also again apply the pattern matching to extract the information that we're interested in. So by looking at all of this, we can see the hyperlinks to the actual news contained in the structure of this here, like this line where my cursor is. It's XML element, log means location, I guess, and there's a just an empty list, and then we have the link. So here we're just like construct the structure here, and it means that once we see this and we see like one thing after it, and then in this it has the URL, and we only want the URL out. So all right, let me evaluate my code, and now getting the article links, and also getting the headlines. They're in a similar but a little bit different structure, but still very much structured. Like for this part, if we see something like containing this title and have some other structures, then we only take out the headline part. So yeah, now this is small function, helper function, to put everything into the data set. Great. So now this is evaluated. We can see these are our headlines, and then these are the URL. And here we're not getting the actual content of the news article, but if we need it, like later, we can definitely do that by just looking at the structure there. So great. Now we can see we have 980 pieces of news in this data, and you can just saw like for it took like maybe 1 second or 2 seconds to do all of that. It's because we're just querying the most basic information, like the headline and the URL. So yeah, now let's see. I'm taking my headlines and I'm sampling like 500 of them, because like 1,000 might be a little bit, it will cost us a little bit more time. So 500, it's good enough. And we're producing a word cloud using all of the headlines, so that we can see like what's going on today. So there are some Man City. Not sure if it's Man City or Man and City. But yeah, there are like some football league information. Says who says, and there are some police. Oh, there are like, yeah, Premier League, I would assume so. So it might be a big football day of today. So yeah, that will the word cloud, it's like one word is bigger, it means that it appears more in these articles, these article headlines. So this will give you an idea like in what topic is most discussed as of today. So yeah, now we have this. We've already have our data. We have all our headlines. What we want to do is that we can use the LLM functionality to ask the LLM to summarize the news article using emojis. So here I'm providing this as my examples, like, oh, if I have this news article, what kind of emoji I wanted to see. And also, like, there's a train delays. So in England, there's no train. So yeah, now let's give it a try. So yeah, now it trains an LM function that has basically like these instructions to do things. And now we just pick 5 random article headlines. And let's see what's going on there. But yeah, noticing that we're using the Wolfram LM service, which is like our in-house LM service. Let me find it. Yeah, I think we do have like some free trials for that. Oh, couldn't find it at the moment. I'll just pull it up like later after we finish this webinar. But yeah, the LM kit, it's an in-house functionality for you to use the LM functions. So yeah, yeah. Oh, this one might be some police looking for cats and but failed, and this one is like maybe some football team has a lot of money, something like that. Yeah, I'm wondering if I can actually see like what the articles are. All right. Yeah, there are like and yeah, something like that. So yeah, that gives you an idea of like what kind of things you can do once we get the data. All right. So now let's look at scaling up with async requests. So what we did just now, as I said, it was pretty easy. It was pretty easy structured, and it was not much information, to be honest. It was just one string, something like that. But yeah, if we want to do like a huge batch of data processing, and we want to actually look at the content of the articles, then it might be something like 1,000-word strings. That might take a little bit of time. So that's when we want to do async requests. This also depends on like how powerful your machine is. But yeah, in general, it will shorten a lot of the processing time. Like for this task, we didn't use async tasks, so it's just doing them one by one. But yeah, we can see how it works in a second. So yeah, for our news site, we pretty much have the pipeline built up already. So now we can just look at another website. So first of all, let me get all of the hyperlinks in ESPN. So get sports hyperlinks stored here. And when we know a web page, there are a lot of irrelevant links, such as like those contact pages. It's not actually news, right? So we also want to filter those links out. So now let's see. Let's see what's in here. Random sample, probably take like 10. So yeah, you can see this one only have the tennis category. It doesn't actually have the article content, and this one I'm not sure what's going on. But for this one, it's actually a story with a title like later. So these are the kind of links that we're looking for our purpose. So here we're just filtering out this structure, like regular expression, something something. This means like anything can be in between here. So we have the ESPN link, and then anything, and then it must have this story in between, and then like something like whatever else. So again, I've put the Wolfram language representation, the string expression here, in the comments here. So if you want to try. But yeah, now let's filter out what we have. But yeah, let's see how much of the sport links we had. So like just from the front page, we get 434 total links, which includes this kind of links that doesn't provide an article. And after we processed it, it went down significantly to 174, and we're pretty sure this 174 are actual like news. So yeah, since here this example, the purpose of this example is to look at the actual content, the writings of the news, then we probably don't want to deal with 174 live. We're just gonna take 30, a random 30 of them, just to demonstrate, so that we don't have to wait a long while for it to process. So yeah. So now we have all of these links. What we're going to do is to process each link so we can get the article out. So first of all, we need to prepare an empty list that can hold everything. So now we have 30 articles. If we pass them to import or URL read, I would say that will take a little bit, a couple of minutes at least. So we'll just wait for them to be processed one by one. But yeah, like Wolfram language is equipped with a lot of parallel computation functionality. So yeah, here usually the parallel functions are like parallel map, something like that, or parallel table, or just parallelize this one. So yeah, anything starting with parallel, that's telling you that it's a parallelizing function. But yeah, here we use a more like web page fetching native one kind of parallel function called URL submit. So what we're doing here, it's let me just run it and I'll explain. So yeah, it is a little bit complicated in the syntax, but we do have a pretty comprehensive documentation center, which you can like take a look at the syntax and how to build it by yourself. So yeah, I'm not gonna go too much into the details here, but yeah, just taking as like we look at each link, each of the 30 link, and then we get the information from each link. And all of these are processed in like 9 seconds. But yeah, again, this is more depending on how powerful is your machine. So yeah, that's pretty much this. And now let's look at how many have we collected, which is we chose 30 links and we should have 30 comes back. So now we have this sport article bodies. Let me show one example how they look like. So yeah, this is basically just long strings of telling you what the story is. So with all of this, we can take a look at we can generate a word cloud of all of these articles to see what's trendy today. So yeah, see some football, see some leagues, Champions League happening yesterday and today. So yeah, this just gave you a basic idea of what kind of things that you can do after you get the information. And now, what we want to look at is that like what's happening in every different country, like what's the sports news happening there. So again, we're gonna look back into the articles themselves, and we have this text cases function, which can take which can basically make sense of the string, and then here it's talking about United Kingdom as a country, and it will just pick those little parts out. And I believe you can also use LM to do that. But yeah, now here we just let it process a little bit. So at the same time, we're picking out the countries, and at the same time, we want to kind of like translate it into a Wolfram language native data collection. We call them entities, which I can show. Yeah, I can show like right now. So yeah, these are this one orange box kind of thing is called an entity in Wolfram language, which means that even though it looks like this, it looks just like a string now, but it means that actually contains more information. Like you can query for the population of United Kingdom, the GDP of the UK, or like the capital city of the UK, the coordinates of the UK, something like that. So yeah, all of these little orange boxes all contains all those information that is built in Wolfram language, which means that you can do more of data processing once you know what you're looking for. So here we have this country got interpreted. Now we would like to see which country got mentioned the most as of our 30 news articles of sports. So United Kingdom got mentioned the most, and then it's United States and it's Jersey. Is it okay? So now we can do a word cloud for that. Also, we can map it out on a real map to see like what's the like here United States got mentioned, here Russia got mentioned a little bit, and because I was asking the UK side for ESPN, so most of the news are in Europe, which makes sense. And we can also generate a word cloud for the top 3 countries. So what this piece of code is doing is that because we have this, So it's basically picking up, oh, United Kingdom, United States, and Jersey. And we take that 3 countries out and we look at news only contributing to those mentioning those countries, and then we see what's going on in their country. All right, so let it run for a little bit. But yeah, this might take a little bit more time because it's looking at like all of the strains. This could be a good case of using those parallel functions too, but yeah, you get the idea. Oh, I got a question in the chat while we're still waiting. Got a question from Marek. Can I automate the execution of Wolfram Language script, for example, fetch and analysis some pages daily automatic? Yes, I believe so. And we do have a webinar of Wolfram script. Yeah, we do have one. I don't know when is the next time that it's gonna be live, but yeah, there's there are definitely some documentation for doing that. So yeah, if you're interested, you can just try to search for that. So yeah, here we have the 3, like the UK, and now we're shaping it as the UK to make it just a little bit more fun. And here is what's happening in the United States. And yeah, so we can also use the article bodies to create a semantic search index, which is just this one simple function. And you just do that in a second. And once we have it, we can use the functions again to ask for like, why has England been in the news recently? Their full schedule for the World Cup. Oh, it's this year. And the Champions League, blah, blah, blah. So yeah. I mean, like, football is extremely huge in the UK, so that's reasonable. Great. I hope this gives you an idea on like what kind of things that you can look into and like a basic understanding of cleaning, importing and cleaning the data. And this is only the code example. We're not opening any browsers or anything. I'm just opening browsers to show you the example, but basically we don't have to open browsers to do anything. So yeah, now we're moving on to some examples that actually getting the browsers to open, and then we can actually do more things there. So this is like this is for more complicated tasks when there are some JavaScripts got involved. And yeah, sometimes when import or URL read is not good enough, it's not getting the correct information out, then we might want to try this automated browser route of doing things. So yeah, first thing we wanted to do is to start a web session. We want to store that web session in a variable, since it's an object that will be passing around every time we want to interact with it. So I don't know, like with my screen set up as for now, where the session is gonna pop up, but once it's pop up, I'll show it. So first of all, we need this start web sessions, and I'm pointing to Chrome. You can point into like other browsers that you like. Oh, great. It's popping up on my current screen, which it doesn't have anything. It's headless. You can see there's no web page link here. There's no title, and there's a bar from Chrome. It's saying that it's controlled by automated test software, which is us. So yeah, once that's opened, remember this is called our session. Once this session is opened, and you can choose not to open it, to be honest, but usually it will be easier for you to visually see what's going on, what's your actions it's doing. So yeah, that's helpful. So now once we have it open here, and now we want this session. Remember, this is a blank session as for now. We want this session to open this example page. Let me do it. I don't know if it will automatically open up or not. All right, it's saying successful. And if I open it now, then you can see the title has changed to example domain, and the link has changed to the one I asked for. And yeah, this one is also just for testing reasons. So there's not much in here. All right, now once that opened, then we can use a web execute function to look at the different parts of the website. So here again, here we can just request for like this tag, this h1 tag. I believe it means the like the header, how big the header is, the text is, something like that. And we can also extract text contained in them. So here, I think it's this one is the h1 element. Yeah, here you can see on my screen it says h1 here. So by getting this object first, we're essentially just getting like this part, but represented in this a little bit complicated way. And we can extract that, the h1 element, so that we actually get the information of it. All right, so yeah, that's the basic idea. Now, remember now this one is on the example domain, and I haven't closed my session yet. I'm still like reusing this session, so it will be the same browser window. And now I'm going to another website that have quotes to script. It's also one example pages that's just for testing, for practicing. So it has all of the text here by a famous human, and then there are some links and there are tags. So great. Yeah, looking at that, we need to look more into the structure again. So yeah, this time I'm just reading my screenshots here. So the text, the actual words are in this span elements. It should be starting with this span class blah blah blah, and it should be like closed by the backslash span. So now we're getting all of the spans. which I can show. We're getting all of the spans in the in this web session, and after getting all of the spans, we need to apparently clean it. So if the span here, we can see the class to be text. There might be some other that has class, maybe like author, something like that. So we're only interested in the actual code. So we're looking at this class being text. So yeah, if it's class in text, then we get the text. Otherwise, do nothing. So now we do that. It should give us a list of all of the information. I think there are about 10. So yeah, now we have the quotes. Let's get the author names. It's a similar structure, but this time it's not a span anymore. It's a small tag and ending in this small. So yeah, we're just getting all of the author by the same web execute session. Yeah, this is just the syntax. And now we have all of the authors too. And just like here is just getting the actual authors out from these objects. So now we're just matching everything with everything. Oh, the first sentence is said by Einstein, yeah, something like that. So we have a nice formatted list. And once we have the nice formatted list, then we can do like later data processing. So here we have a tiny function, quote of the day. So I evaluate it, and here I'm just doing a formatting, and noticing that I'm just using a random integer to pick from maybe like the 6th of the list. And this once function is that you only evaluate it once in your kernel session, which means that if even though it's random integer, I re-evaluated it because it has been evaluated. It got remembered, so my code of the day won't change. Like if I remove this once, then like no matter how many times I evaluate it, it changes. So yeah, that gives you another idea on like once we get it, what do we want, and gives you an idea of how to use the web execute function. So yeah, when you're done with your session, remember to delete it to avoid unused process running in the background. It is pretty easy to forget to do this when you don't have a browser running. As we can see, like once we delete the object, the browser just went away. So yeah, here is another more like real example. All right, so yeah, I'll go through this one a bit faster because we've already have the basic understanding of how you should work in the browser. First of all, we want to start our web session, and this time we want the visibility to be false. So noticing that I don't have another new Chrome site open. So yeah, let me open this in another browser so that you have an understanding, like instead of I'm just talking. So yeah, we want to look at the blood type distribution by countries in Europe. So here we're just getting this table here, this first this table here, and what we're looking at is the A blood type, and A blood type is including A plus and A minus, these two types. And I believe the list of countries, it's like all of the countries in the world if they have data. So we'll need to do some filtering like once we get all of the information. So that's the basic idea. So now, once we open the, we have the session, and we want the session to open the page, and then we want to take that first table we saw out. So yeah, now we have the table, and get the text of the second table. For this specific web page, there's an empty element with the table tag that gets added to our list. So yeah, that's goes back to we should inspect the HTML structure of the website and then decide like which table we're getting. So here we're getting the second table as what we saw there. And the next step, once we get the raw table, we will have to do some string cleaning. So yeah, here we're mixing string expression, which is the Wolfram language regular expression and regular expression to extract the country names from the table. So yeah, it is more like what can actually helps you. Doesn't matter if you want to mix it or not or anything. So as long as it works in your mind, that's great. So now we're getting this country list. So this should be containing like most of the country in the world. Not really, but still like this is more than Europe. So now we're processing the A plus numbers and A minus numbers, which again, if you remember the table, there are like two columns that containing all of the population percentage of people have A plus blood type and A minus blood type. They're just like plain numbers. And A minus is it looks about the same. So yeah, for all of the blood type A people, it is including A plus and A minus people. So we're just adding those together. And noticing that even though this looks like numbers, they're strings. So we have to use two expression to basically translate this into numbers so we can actually add those up. And I have to make a comments there. Like in real production, be extremely careful to use the function to expression. It might translate something like to weird stuff, or it might have errors processing if your original, like let's say your original string contains invalid characters. So it is not a very sustainable way to do this kind of thing. I would say maybe use interpreter using that function to interpret whatever. Yeah, to translate your strings into numbers. But yeah, here it's because I know my numbers, so to use to expression it's okay here. So now I'm just getting all of the numbers for blood type A people. And then we can create an association thread which associates the proportion of people with A blood type people. Now we can see it has country name and the number. It's a percentage. So yeah, now it has like has China, which is apparently now in Europe. Now we want to process all of this and only get the European countries. So here I'm using this like natural language processing, like by taking all of the Europe countries' name. Then we're going to interpret. We're using the interpreter to get the entities versions of all of the European countries. And these intersections of association, which is this whole thing, we want to look for the intersection of these data set with the Europe country names, which just basically filtering out all of the Europe countries data. And now we have another we have all of this, and now just basically just mapping those back, get these final association. Now we can see that we have this entity, and then we have the number associated with that. Once we have the entity, it means that we can actually do more. So yeah, here we're just using the histogram to show. All right, so yeah, that's the idea, and the two tips are for the real number. And again, once we're finished, remove it. It is super easy to forget them. All right, now we are looking at the manipulating web pages. For the previous one, we basically only get static data, but for this one, it is the Association of Tennis Professionals. So here we're opening a session. Let me move this around a little bit. So first of all, we want to start our session as a blank one, and then we're opening this page. And here we see the first thing we wanted to handle is that we see the cookie spanner. And we need to click the cookie banner first so that it goes away, so that we can actually get into some other JavaScript functions, other buttons inside the web page. Otherwise, like no matter where we click, it just won't do anything. So yeah, web execute can actually help you with doing all of that. So what we're doing here is that we use web execute to locate all of the buttons with the button tags, and then we need to find the actual cookie button, which you can see by the word here, accept all cookies. So yeah, now once we locate the cookie buttons, and we can still use web execute click element, which will do it automatically. Please look at my my left-hand side website once we evaluate it. Then I didn't do anything. It automatically clicks. So yeah, once we actually get into the web page. So yeah, some people only care for like the upper side of the player stats, but we wanna do more. We wanna get all of the information. So here there's a load more button. Again, we're doing a similar thing as clicking the cookies button. So now we're locating the load more button, and load more button has an A tag. So it looks at all of the elements that has an A tag, and you can see here once my code on the right evaluates, and on the left-hand side, it gets the load more button automatically. then it loads. So yeah, now I have the basic structure for me to get the information. All right, so here we have like 3 different tabs of is my internet not working? Yeah, we have these 3 different tabs of information. So now we're looking at the serve tab, and we can do some cleaning up. I'm not going into too much detail of it. Great. I think I broke it by just random clicking, or my internet is not working. Let me redo it. Yeah, sometimes it happens because yeah, I'm just automating it. I'm basically a bot currently. So yeah, sometimes websites will prevent that, which is very much understandable. So yeah, let me quickly redo all of this. And that's clicked. This needs a second. All right, now it's clicked. I will just get my information again. But yeah, getting information from website, it's a very dynamic process, I would say. Something works yesterday, it might not work tomorrow. So yeah, before this webinar, I've actually been like changing the structure, changing the filtering a lot for some of the code, just because their website might change and it might not be like a extremely robust process. But anyway, now we get our information. This is for the first this serve leaders, and we have our serve rankings now. All right, now that information was got, and I can safely remove my session. So remember, there are like 3 different other tabs. So I'm doing exactly the same thing, but the open page was just clicking through the different tabs. So yeah, that's already been a pretty automated process. I open the page, and I start my session, and I open my page, and you can see I only running my code once. Opening my page, and the cookie button got clicked, and I'm just waiting for it to find the load more button again. And yeah, you can see like it pops from the 50 to 51. So yeah, just by like one running of the code. And noticing I have this pause 3 built in, because sometimes web pages need some loading time. So if you don't add this, it might be looking for information before everything is loading, which end up not having the correct thing to click. So yeah, just remember to give it some time. Great. Now everything is pretty much the same and automated again. I can just run all of my code in one run, and it's just getting the return ranking and the person's name here. Now I'm closing this. So again, I'm doing it again, opening a session, click the cookies button, and waiting for the load more to load. Yeah, I would say like the load more takes a little bit longer than I'm expected, probably because there are more A tags than button tags, so it needs to go through a little bit more. So now, once they're all loaded, again, I'm just running a huge like getting the data and cleaning and formatting the data. Exactly the same thing. Now this is the under pressure ranking with all of the information. Now closing my session. And the final page we care about is the actual ranking of the players, like, oh, who's the number one of tennis in the world as for now. So again, let me start my session with a blank page and opening the page. So yeah, for this one, yeah, I'm just clicking the button by myself. So now we can see on the left hand side, it has the people's name, has their age, and has this little flag by their picture. So that little flags can tell like which country they're from. But again, we need to find the structure for wrapping those flags. And here is the code to get all of those country codes, which is basically their flags. And again, once we get the country codes, we can use interpreter to translate them into entities. Like this is Italy, but there will be some cases that it might fail. It's probably like it might not be a standard way of saying things. Yeah. Again, we would like to clean and format those data. And now we have this helper function to get a list of the countries that got involved. And I believe it should be a ordered one, as first one is from Spain, second one is from Italy, I believe. So yeah, let's give it a minute for the to process. It's taking a little bit longer than I thought. But yeah, great. Now it's processed. We can see it's actually like in order, so which is great. And getting the rankings, which is just basically we're getting the names of the players, and we see those 8 tags again, and again it is processing. But yeah, because for this one, the order of how we're getting the data is the same as the world ranking of the players. So we don't need some extra processing of those. We're just basically mapping everything as how they're presented to us already. All right, now that's processed. We can get the anchors that contains the player names. All right, when that's processing, I'll just show the one that I did before. So yeah, see, we can see the world ranking as 1, 2, 3, and have player names and have their country. Great. Now that session is finished. Remember to remove it. And now we have our previous tables. We can join everything together. This was not processed correctly, but now it is. And let me reevaluate this. Great. Now everything is put together. We have the world ranking, we have the name, and have their country, have their serve ranking. A lot of them doesn't make any sense to me because I don't watch tennis. But yeah, we now see the return data, and also have the pressure, under pressure rating data, something like that. So yeah, once we get a nicely formatted data, we can like do some more processing of it. So here we're looking at some players has like really good serve, but the world ranking is not too great. Means that they might have some like other areas that they need to improve. And these players can serve really well, but cannot return. And we can also use this code to generate a, like, you can see whichever data you would like to see, and by hovering over you can see like, oh, which player, this player have 35% of breaking points converted, and the under pressure rating is like 240. Yeah, I'm not exactly sure what that means, but you get the idea of like matching the data and help you to visualize to see what's going on. Great. So yeah, that's our clicking button example. There are some web pages that's more that's more complicated than just clicking two buttons will lead you to a real website. Yeah, because nowadays a lot of the websites are like you have to scroll down. They gave you an infinite scrolling structure. So yeah, so JavaScript execute has some basic functionalities like clicking these buttons, but yeah, if it's for scrolling, then that's not built in. But good thing is that you can actually write your JavaScript function to do that. So yeah, now let me move this a little bit. So first of all, we start our web session, and then we're looking at our own Wolfram web page, which is this page, and you can see the scrolling bar here. It's pretty short, but once I start scrolling, you can see like more things are loading more and more, and then it just suddenly like loading a lot more. So yeah, what we are going to do here is that we tell our browser to keep scrolling down until the bottom, until the height stopped change. This is some very complicated JavaScript code here. I would have to say that I don't completely understand them, but helps. So great. So yeah, now let's evaluate it, and you could see that it just like magically went down to the bottom and it's stopped loading anymore. So yeah, we will consider this one as the whole website. So now once we have the whole website, we can do the same thing like the web execute and getting like links, similar thing. And what we're interested in here today is we want to look at all the hyperlinks for each of the example. We want to like later open them up. So it's good that we get all of the hyperlinks, which in this case it's 200 something. And we need to process them because again, there might be links that like accept the cookies. There might be links that goes to the front page of Wolfram Research, which it's not the links that we wanted. So here we're just cleaning it since we know the structure of a example page will be look like this. So all right. So now it's it's getting to 94 links together, but like this definitely looks more than 94, right? Because I have to scroll a long while. And the reason of it would be there are some structural changes of the website. It used to give like the correct number of links, but now because they changed something at the back end, and there may be calling APIs, there may be like loading in like JavaScript, loading in their memories that by saving resources, they might only be like showing probably only the links here. That's what we can get. So yeah, sometimes it's just their changes. There's nothing we can do about it. When our previous approach now it stopped working. But yeah, there are always like other ways to approach this idea. So let's close this session. And yeah, for the next part, we don't have a lot of time. I'll just talk through it. I'm not demonstrating it. So noticing that our web page has different categories and has astronomy, has audio. And once we get into like a different knowledge page, it doesn't change anymore. It's not the infinite scroll. It just loads the whole list completely because for calculus there are 40. It's not extremely consuming of resources, so could afford for the whole page to load. So yeah, now I'm starting another web session and then getting all of the links from there. So basically what's going on here is we build these category links. We go to astronomy first, and then we got all of the hyperlinks, all of those filtered hyperlinks out of astronomy, and we store them. And then we close that page. We go to audio processing next, and then we get maybe like 10 other resource links there. So yeah, we put all of those links together, and this times we have about 378. That's all of the examples. And now we have a helper function to extract the author of all the contributed example. So yeah, on each of the example page, there will be a section saying like, oh, author, who. Great. Now, when the authors are collected, we check the length of that. It's also the correct number, which like later, once we have that, we have a list of authors. Then we can also do some analysis on who contributed more. So here we have Wolfram stuff, 200 something. And we have Stephen Wolfram himself. And again, once we're finished, then we remember to delete the sessions. Great. So yeah, conclusion of today is that we have some powerful functions for you to extracting information, data from web pages. We've covered import and URL read. We've covered web execute, and also those async tasks for you to save time. And we've also talked about the unstability of getting information just because the web page might change. But yeah, this just gave you a basic understanding of how the process would be like and what kind of things you could do after you're getting your data, and also like combining all those information with those building Wolfram language entities to get even more. All right, that's all of it today. We have some other like resources helping you to get better understandings. You can check your access if you're with an institution to see if already have Mathematica subscription. And you can also go to the WolframU webpage to see there are other webinars, courses, events, something like that. And this is not data science workflow, but these are for like web pages, and then also processing of the strings and characters. And well, once we get the data, then it might end up being data science workflows. And there are some public resources. Great. Thank you for today. And we're having another webinar, writing a Wolfram language function next Wednesday. So yeah, if you're interested, please scan the QR code or use the link to register. Great. If there's any questions, I will be around for a couple of minutes. And so yeah, it was a great webinar. Thank you. Yeah. Speaking of some of the stuff that once you get the information, I know that we have some collecting news, like a daily news spot, just by collecting news and use some LM to process it, and then I get an email for the news that I might be interested in. And for me, I personally use these kind of techniques to track if there's something that I'm interested in is in stock or out of stock. Yeah, what other things? Yeah, there are a lot that you could do with these. All right, great. I still didn't find the LM kit offering. I'll ask the our events team about sending out those links. So yeah, great. I guess that's all for us today. Thank you so much for attending. See you next time in our webinars. Bye.